Okay, this is the start of the chemical and physical changes in matter lab. So I've got my 5 test tubes. I have my Bunsen burner. This is a metal crucible in a clay triangle. And to start with, we're gonna heat copper. So the first thing we're gonna do is take copper, which is just real thin copper. I've rolled it into a ball, about 2 centimeters. I'm gonna add it to my crucible, and then I'm gonna get the mass of that crucible. So I'm gonna turn on the scale, and we're gonna record the mass of our crucible with the copper inside. So make sure you go ahead and write that mass down. Next, I'm gonna go ahead and put it back up in my clay triangle. All right, I relit my flame. Now I'm gonna lower this. I want this metal crucible to be down at the top of the inner cone. So I'm gonna go ahead and lower that, and I'm going to let this heat for about 5 minutes, and then I'm gonna let it cool. So I'm actually gonna come back to this once we get to the end of the lab. Okay, so our copper is done. I'm letting it cool, and I'm gonna move on to number 3, which is heating a wood splint. So if you look carefully in my test tube, I took what's basically a coffee stirrer stick and I broke it into about 4 parts, and we're gonna heat it up over this open flame. You are supposed to write down 3 observations. Remember, your observations are like your senses. I'll describe some things, but some of these things you should just be seeing for yourself. Notice I'm heating it at the tip of that inner cone. All right, so one of the first things I can see is that the test tube glass is getting foggy and wet. Condensation is building up in there. I'm starting to see smoke come out of the top. The inside of the test tube is turning like a yellowish brown. The smoke is also kind of a brownish color. And I'm not sure if you can hear it. There's kind of a popping sound near the mouth of the test tube. The bottom of my test tube is turned pretty black, and if you look closely through the test tube glass, I can see that that wood is no longer that pretty brown color and shape. It's kind of shriveled and black. All right, moving on to NaCl and water. This would be number 4 on your data table. So the first thing that I'm gonna do is I'm gonna scoop up, this is salt, this is NaCl, and I'm gonna put it into my test tube. I'm actually gonna get just a little bit more and add it to the test tube. Then I'm gonna take, I already put some water in here, I'm gonna go ahead and add it. And so now all I've done is I have a solution of salt water. I'm gonna put my thumb over this, and I'm just gonna shake it up real quick so I can make sure that that salt dissolves completely. I could add more water if I need to. So you should be writing down some observations right now. What do you see happening? Right, initially there was like a clump of salt at the bottom. But I've pretty well got that dissolved. There may be a few crystals down there. Give it another little bit of shaking. Okay, so the salt is now completely dissolved. So take a minute. What does this look like? What happened? How did it change? All right, and now we're gonna heat it up. So now you are recording observations for heating the salt solution. Not sure if you could hear it, but there is some like popping noises. You can see the water boiling in the test tube. It's kind of shooting up the side here. I'm not sure if you can see, but a little steam is being released out of the top of the test tube. But I'm going to continue to boil this until there's no more liquid. All right, so I'm seeing lots of popping. And now I have a test tube filled with what appears to be like a white powdery substance. Okay, we are moving on to experiment number 5. This is NaCl and AgNO3. AgNO3 is called silver nitrate. So I'm gonna make another saltwater solution again. I'm gonna add a little bit of salt like I did before. I'm gonna add some water, and I wanna get this salt solution to dissolve. Oops, just like I did last time. And that looks pretty dissolved. So we're gonna put that down. So now what I'm gonna do is the directions say to add AgNO3 drop by drop until a change is observed. So this is my silver nitrate. And you're gonna record changes that you see in this test tube. All right, so record those observations. But remember, we want to be very specific. Did the change happen right away? Did it take a minute? Is the change throughout the test tube, or is it only in one part of it? What color is the change? What about the consistency of the new solution? Those are all parts of your observations. Okay, moving on to our next one, FeCl3, which is iron chloride, and KSCN. KSCN is a skin irritant, so I'm going to be very careful with it. Our directions say to put 5 drops of FeCl3. 1, 2, 3, 4, 5. And now it says to add the KSCN 1 to 3 drops until a change occurs. So we're looking at that yellow solution. It only took 1 drop for that change to occur. So what happened? All right, last experiment. We're gonna do 5 drops of FeCl3 again. It's that yellow solution. 5. And this time, instead of adding KSCN, we're gonna add silver nitrate, 1 to 2 drops of silver nitrate. All right, take a look. I'm going to try to put that against that black background. One of the things I noticed is that the top of it appears kind of chunky, and the bottom of it is like a pale yellow cloudy color. All right, my crucible has cooled off. This is our copper. So remember what the copper looked like at the beginning, and this is what the copper looks like at the end. And that is our final mass of our copper. So go back to that first section in the data table. Go ahead and record that new mass and describe any changes in the metal. Okay, now that you have all your observations, you're going to fill out this section. What it's asking you is for each of your experiments, was it a chemical or physical change? And provide evidence for what you chose. So for example, if I say that heating copper was a chemical change, I would write chemical, and next to it, I would write something that I saw or observed in the experiment that supports that copper heating is a chemical change. If you are unsure about these, I would go back to your notes, go back and look up the definitions for chemical and physical change, and how do I determine if it was a chemical or physical change.